In this lesson, we're going to talk about atoms, ions, and isotopes, and a notation that can be used to represent them. So within the nucleus of every atom, there are positively charged protons and neutral neutrons. All atoms of a particular element have the same number of protons in their nucleus. For example, all atoms of carbon have 6 protons in their nuclei. And this number of protons is known as the atomic number. So the atomic number refers to the number of protons in the nucleus of each atom of an element. So continuing with that example, carbon's atomic number is 6. It has 6 protons. And the atomic number is used to arrange the elements on the periodic table. So here's the periodic table, and you can see these little numbers up in the corner, 1, 2, 3, 4, keeps going, right? So they're in order of that number, which is their atomic number. So if you need to know how many protons are in the nucleus of an atom, you just need to go to the periodic table. For example, if you wanted to know the number of protons in a nucleus of iron, you would find iron on the periodic table, which is right there, and you would look up in the corner for that number. So iron has an atomic number of 26, or 26 protons in its nucleus. There's another number that's associated with atoms, and that is the mass number. So the mass of an atom comes from the combined masses of its protons and neutrons. The electrons aren't considered because they're so small that scientists consider their mass to be approximately 0. So we don't talk about electrons when we're calculating the mass of an atom. The mass number is the total number of protons and neutrons in the nucleus of one atom of an element. So we can summarize that information about an atom using this notation. The large X represents the atomic symbol. So for iron, right, that would be Fe. For carbon, a C. At the bottom here, you would put the atomic number, which comes from the periodic table and indicates the number of protons. At the top, the mass number, which equals the number of protons and the number of neutrons. Often this notation will be simplified by omitting the atomic number. And that's because you can always find it if you look at the periodic table. As long as you have the atomic symbol, you can find the atomic number. However, the mass number is not found on the periodic table and must always be provided. So let's look at an example. So this is an atom of fluorine. The atomic number at the bottom indicates that this atom has 9 protons. The mass number indicates that it has 19 protons and neutrons. So we can determine how many neutrons this atom has by subtracting the atomic number from the mass number. So in this example, the number of neutrons is 10. 19 minus 9. So what about those electrons? We know that atoms are electrically neutral. Therefore, the positive charges, the protons, and the negative charges, the electrons, have to balance each other out. So in other words, in the neutral atom of an element, the number of electrons is equal to the number of protons. So for an atom of fluorine, it had 9 protons, so it's also going to have 9 electrons. When atoms lose or gain electrons, they're called ions. And when they lose or gain electrons, they're going to have a net charge. They're not in balance anymore. There are 2 types of ions: a cation, which has a positive charge because it has lost electrons. So it has now more protons than electrons. An anion has a negative charge due to a gain of electrons. It now has more electrons than protons and has a negative charge. So one way to remember which one is which, cation versus anion, is this little trick. So you can always remember the cation. It's the positive one. When you're talking about an ion, the number of protons and neutrons are the same as the neutral atom. Only the number of electrons has changed. So if we look at an example for a magnesium ion, the 12 tells us that the atom has 12 protons. That's the atomic number. The mass number of 24 tells us that it has 24 protons and neutrons combined, which means it has 12 neutrons, 24 minus 12. Now that charge, 2 plus, tells us something about the electrons. So when a magnesium atom is neutral, it's going to have 12 electrons, same number as protons. But in this case, it has a charge of plus 2, positive 2. So it must have 2 more protons than electrons, which means it has lost 2 electrons and now has 10. So this magnesium ion has 10 electrons. Okay, the next term is isotope. So all atoms of the same element have the same number of protons. However, they may have a different number of neutrons. Isotopes are atoms of an element that have different numbers of neutrons and therefore have different mass numbers. So an example, oxygen has 3 naturally occurring isotopes: oxygen 16, oxygen 17, and oxygen 18. It's all oxygen, they've all got 8 protons, but their nuclei have different numbers of neutrons. Right? Oxygen 16 is going to have 8 neutrons. Oxygen 17 will have 9 neutrons, and oxygen 18 has 10 neutrons. Some isotopes have a nucleus that's unstable, so the protons and the neutrons don't get along. And so when that nucleus is unstable, it is very likely to decay, so to break apart into a different, often more stable nucleus. And so these isotopes are called radioisotopes. And the process of decay is called radioactivity, and it just happens spontaneously. And when it happens, it releases energy and subatomic particles. And we're not going to talk too much about radioisotopes, but just that you know that they exist and that their nucleus is unstable. So that's a general overview of atoms, ions, and isotopes.